Hello and welcome to the Grand Canyon South Rim field trip. We're going to be taking some look at some spectacular geology from the DesertView viewpoint and from a hike down the Tanner Trail. A lot of talk about and a lot of look at the Grand Canyon supergroup, motion on the Butte Fault and its role in creating the Tanner Graben and the overall history of the Grand Canyon area. And we're also going to take a quick walk down the Beamer Trail to take a look at the confluence of the Little Colorado and Colorado River. So where are we? This is an oblique satellite view of the Grand Canyon area. Let's zoom in on roughly this area and look in a little more detail. So here we are. This is the road that leads along the rim and then eventually out this way to the little town of Cameron. So here is the DesertView watchtower, and here is Lippin Point. That'll be important here in a second. We're going to be seeing from DesertView looks more or less to the north. And from the Tanner Trail, which leaves from Lippin Point and kind of wanders down this way, we'll be stopping roughly here and again looking towards the north. So the structure I'd like you to notice from this image is here. Okay? This area is dominated by these red rocks. This is the Docks Formation. We'll see this a whole bunch of times here in a minute. But notice these dark black rocks here. This is part of the Cardenas basalt, a big lava flow that erupted during the late Proterozoic. And this structure, it's called the Tanner Graben. This is a very important structure in terms of understanding the geologic history of the area. All right, a look at the geologic map. Here is the DesertView watchtower. We're going to be looking at some images to the north. And again, the Tanner Trail leaves from approximately here. We'll walk down this way, stop here, and take some more images towards the north. So what you're seeing here on the geologic map in this area is mostly the Grand Canyon supergroup rocks, the Proterozoic sedimentary and igneous rocks, which we'll be looking at here in a second. In terms of the cross section, we're going to be looking at kind of the middle and upper section of the supergroup, talking about that mostly. The Paleozoic rocks are also there from the Great Unconformity from the base of the Tapeats all the way up to the Kaibab. We'll be mostly focusing on the supergroup rock here in this field trip stop. All right, here we are. This is the view looking towards the north from the DesertView watchtower area. And there's quite a bit to show here, but what I want to do is to zoom in a little bit. Let's first take a walk down the Tanner Trail and zoom in on roughly this area here and take a close look and see what we've got. All right, so here we are. It's a different day, so the lighting was quite a bit different, but the view is the same. So what I want to point your eye to is this. So here's the contact between these red rocks. This is the Docks Formation. Here's the contact between the black and the kind of purpley rocks. In the middle here we have the Cardenas, and above here we have the Nankoweap Formation. So the contact between the Docks and the Cardenas is there. Off to the right, again, we have the Docks, and above it, back here, the Cardenas. But right in front of us, here's the Cardenas, dropped down quite a bit. Notice the elevation difference between the contact between the Cardenas and the Nankoweap here, and the contact between the Cardenas and the Nankoweap off to our left. What we're looking at is called the Tanner Graben. On the right-hand side is the Butte Fault, roughly here, separating these black rocks on the left from the red rocks on the right, and there's another splay of this fault zone here on the left. And in both cases, the inside has dropped down relative to the outside. So these are both normal faults, opposing normal faults you might call, because they dip in opposite directions. And it's produced a geological structure called the Tanner Graben. So let me illustrate up here how this works. So on the left, I'll draw the before. So here's the Nankoweap Formation, here's the Cardenas basalt, and here's the Docks Formation. This area was under extension during the late Proterozoic, during the breakup of Rodinia, and that produced normal faults. And in this case, we have one that dips this way. That's this one. We have one that dips this way. That's the Butte Fault. That's this one. And so motion was like so. So there's the before. Let me try to sketch the after. So again, on the left, we have the Nankoweap, the Cardenas, the Docks. On the right, the Nankoweap, the Cardenas, and the docks. But the middle block here has moved down. So now we have the Nankoweap Cardenas roughly there, the Cardenas docks, here. So now we have the Nankoweap, the Cardenas. In our case, the docks down here is below the river. You can't really see it. This is a very important structure. It helps us understand the Proterozoic history of the Grand Canyon. And even the more recent history of the Grand Canyon. The Butte Fault, which is this side, has played a very important role not only in the Proterozoic history, but the much more recent history. So let's go down to the river and have an up-close personal look at this graben. So again, here we are. We're standing roughly here, looking towards the graben, again on a different day, so the lighting is much different. Here's the left-hand side. Here's the fault on the left, this one. And here's the right-hand side. The fault on the right, which is this one. So the Butte Fault was born, so to speak, during the breakup of Rodinia about 750 million years ago, and it started out as an extensional fault, as a normal fault. Okay, but more recently, it's been reactivated as a reverse fault. So if we get even closer, zoom in on the Butte Fault as much as possible. Okay, so here's the Cardenas basalt, here's the docks formation. The Butte Fault also shows evidence of its activity as a reverse fault during compression of this area during the Laramide orogeny, roughly 70 to 40 million years ago. What I want to point your eye to is these sediments, which are flat-lying off to the right. Okay, but if you follow this line towards the fault, these all kind of tilt upwards, like so. And this is because the Butte Fault here was reactivated as a reverse fault. In other words, these rocks moved up relative to those on the right and essentially dragged them and tilted them upwards during that reverse fault activity. That motion on the Butte Fault during the Laramide orogeny, again, here's the Butte Fault we were just looking at and its extension across the landscape. Its extension across the landscape matches up here. So this was a reverse fault here, and so the rocks on our left side moved up relative to those on the right. And you can clearly see that here from DesertView, as in I've drawn in these orange lines. The motion on the Butte Fault, compression and uplift on the Butte Fault is what created the East Kaibab monocline, the Kaibab Plateau, which is off to the left. And really without that uplift, the rivers in the area wouldn't have the energy to carve the Grand Canyon. And so it's really important for explaining the presence of the Grand Canyon in the first place. So we're also going to take a hike, and I'll show you a bunch of really nice images of a hike on the Beamer Trail. It's a fairly faint trail up the eastern part of the Grand Canyon. And it hikes up to the confluence here of the Little Colorado, which is this kind of blue milky river, and the regular Colorado River. The Little Colorado is spring-fed, and those springs are really rich in minerals, and so it gives us this really beautiful milky color, milky and blue color as it flows along. One last thing along the Tanner Trail, an instance of what's called stream piracy. This is where the one stream in effect steals water from another stream. So here we have a panorama view from about 3 miles down the Tanner Trail. And what we're looking at here in this direction, this is 75 Mile Canyon. And here is Tanner Canyon. Okay? And so I'm showing you the panorama so you can see both. Things get a little distorted when you have these panorama images. So here's just regular photographs looking down 75 Mile Canyon and Tanner Canyon. What I want to point your eye to is just how steep it is here. This is a few hundred feet drop off down there, where this is a very gradual canyon. Okay, so let's get rid of these pictures just to get them out of the way and explain what's happening here. Okay, so we are standing right now in Tanner Canyon. The water behind us, whenever it rains, it kind of flows down this way and flows down Tanner Canyon off to our right. However, because this is so steep here, the sort of head of this canyon is eroding towards us. When water flows faster, it's more capable of carrying away sediment, and so erosion is faster. And so 75 Mile Canyon is eroding much faster than Tanner Canyon. And so slowly over time, the sort of top of this canyon is going to march towards us as it erodes. And eventually, as it erodes and erodes and erodes more, the top of 75 Mile Canyon is going to move backwards towards us like so, backwards towards us like so. It's going to erode and erode and erode more, and eventually intersect the path of water that normally flows down Tanner Canyon, and instead that water is not going to flow down the steep 75 Mile Canyon. Stream piracy, effectively 75 Mile Canyon as it erodes and moves, the headwaters of 75 Mile are going to move up canyon and steal or pirate the water away from Tanner Canyon, and that flowing down Tanner Canyon is going to take a left and then flow down 75 Mile Canyon forever thereafter. All right, thanks for listening. Go take a look at the images for yourself, and I will see you at the next stop.